Hello. I want to talk today a little bit about tangent line problem. This is a famous problem and a very foundational problem in calculus. So, to get started, what we're going to need to know is the idea of a secant line. So given a curve, if I put 2 points on it and connect those 2 points up, that's called a secant line. I can use that to get the idea of a tangent line. What I'd like to do is I'd like to give you a small demonstration here. I've written some Mathematica code to generate a picture. Specifically, this picture is sine of x. I can change it to cosine of x or other functions that I have predefined here. So we're going to start with y equals sine of x. So the idea here is I have 2 points, P and Q, and I can move them freely about the curve. If I want to put a secant line between them, I'm going to connect those 2 points up and draw a line. I can generate a slope out of this, rise over run. At the point P, if I move it, the line travels with it. The idea of a tangent line is a line that barely touches. Given 2 points, we can calculate a slope. Given 1 point, we cannot calculate a slope without doing a little bit of extra work. So one of the ideas of calculus is how can we determine what the slope of that tangent line is? So using this picture, if I take the point Q and move it closer and closer to the point P, what's happening to the 2 lines? Well, the slope of the 2 lines are getting closer to each other. And in fact, if I get these points P and Q very close so that they almost overlap, key thing here is almost overlap, I can see that the lines are looking almost the same. In other words, the slopes are very close to each other. So that's the idea of how we can use a secant line to approximate the slope of a tangent line. What I'd like to do now is a little bit of handwritten work. So let me switch over to that view. In this handwritten work, I'm going to look at some algebraic steps. I'm not going to solve any algebraic steps in this particular video. I will wait until the video on. So here's the idea. If I have, say, an x and y axis, and I have a function on it, we're going to give this name of f of x. You can use whatever name that you want, or whatever name that you're given in the problem. The goal here is to find a tangent line to that specific point. So what are you going to need for this particular problem? You're going to need to know a slope, and you're going to need to know the coordinates of the point. Well, the coordinates of the point, that's going to be given. It's not going to be given to you in numbers, but in general. So I want to say that the x coordinate of this point, that means the y coordinate of this point is f of c. To refer to this point, I'm going to call it P, just like we did in the Mathematica video. I'm going to choose another point on this graph. I'll give it the name of Q, similar as into the Mathematica notebook. And this particular x value, well, I'm not going to give this x value a direct name. What I want to do is say, let's suppose that this distance is h, or it's h units over from c. That means this particular value of x, c plus h. So this point has an x coordinate of c and a y-coordinate f of c. If I connect these 2 points up with a straight line, and I will try to do my best on that, I can figure out the slope of that line. So the slope of that line, and I'm going to call it SEC for secant line. It's going to be rise over run, delta y over delta x. This is going to be the change in y, which is going to be one y coordinate minus the other y coordinate, and then the corresponding x coordinate. You may notice that the denominator can be simplified a little bit. In fact, it's just h. H is the distance between the two x values. In other words, it is the change in the x value. This particular expression is called a difference quotient. And it is one of the building blocks in calculus. In the next video, I would like to talk about how to use this to actually generate the slope of the tangent line at P. I hope this video was helpful. Have a great day. See you later. Bye.